All right, a little bonus video here to finish off our discussion of length. We have some ideas of speed, and speed is really just, or rate, is really just a combination of length and time. Okay, in particular, rate or speed is distance divided by time. That's our formula generally, and I always remember that formula because I know speed is measured in miles per hour. So you have a distance or a length divided, per means divide, by time, okay, by hours. So it's distance divided by time is equal to your speed or your rate. So I remember that because that's our common measure of speed, I think, when we're driving down the road. Those are probably the most used speeds. There are other examples of speeds, if you're into target shooting, guns and archery and stuff, you're looking at feet per second for speeds of projectiles, your arrows or your bullets or whatever. A lot of times you look at feet per second. So those are other units of rate that are common, but typically we think of miles per hour when we think of speed, right? And so when you go over into Canada, if you go across into Windsor or over across the Port Huron into Canada there, what's that city on the other side of Port Huron there? I don't remember. But anyway, when you go over into Canada and you start driving on their highways, if you're trying to go up into Toronto or something, or cut across to Niagara Falls and you want to go through Canada and not go around through Ohio, then you're going to find speed limits that look a lot faster than what we drive, right? The speed limit signs will say things like 100 kph. You're like, oh cool, I get to drive 100 now. But you got to be careful. That is not the normal 100 that we're used to. It's a different unit of measure. They're using kilometers per hour instead of miles per hour, okay? And so most of you will have on your speedometer a conversion, right? You'll have big numbers in English, miles per hour, and then you'll have smaller numbers underneath that to measure kilometers per hour. It doesn't always happen, but a lot of our cars are equipped with those to begin with. But you can do a quick conversion using our conversion techniques now, our dimensional analysis, if you can do some mental math quickly and remember the conversions. So if I want to take, so I've got here two different conversions. I want to take the kilometers per hour and convert them into miles per hour, mph. And then, just for fun, we'll turn it into feet per second. FPS is feet per second. Okay, so let's go ahead and do both of those conversions. We'll do miles per hour first. So if I want to take that, now when you do a rate of speed, we said in the past we just take our unit, our given information, and put it over 1, right? Well, here I want 100 kilometers per 1 hour. Now, when you're looking at rates, you include both units in the fraction, okay? Kilometers on top, hours on the bottom, because kph, kilometers divided by hours, kilometers per hour, okay? And it's per 1 hour, okay? So that means at a speed of 100 kilometers per hour, in 1 hour, you would drive 100 kilometers, right? So it's 100 kilometers in 1 hour. So that's how we set up our fraction. Then we need to convert to miles per hour. So we need the hours to stay. I'm not trying to convert the hours. I just want to convert the length part of this, or the distance part. So the miles, we want miles to be on top and the kilometers to be on the bottom. So when we have our mile to kilometer conversion, and remember, there is 1 mile is approximately 1.6 kilometers, okay? So I take 1 mile and divide by 1.6 kilometers. The kilometers cancel out, and I'm going to be left with a mile per hour rate. Those are the units that are left that are uncanceled. Now I have to do that that calculation. It's 100 divided by 1.6, and that's 62.5. So when you thought you were able to drive a speed of 100, you're really looking at 62.5 miles per hour. And if you look at your speedometer gauge in your car, the needle, when the needle is right on 100 kph, it will be reading 62.5 mph. Okay, so that correlation, on your speedometer, those two numbers will coincide. Okay. Now, I also said I wanted to convert this into feet per second, right? Now, in order to get to feet per second, we kind of have to go through the miles per hour stage. We have to get the kilometers to miles and then the miles to feet. But we also have to get the hours to seconds. Okay, so it's a multi-step process. Now, I could work with what we already have, but I want to start this one from scratch, just in case it ever came up where you needed to make that conversion directly. Okay, so I'm going to start out with my 100 kilometers in 1 hour. I need to multiply by 1 mile in 1.6 kilometers. Okay, that cancels out my kilometers. And then I need to convert my miles to feet. So I want, let's see, it's 5280 feet in 1 mile. So that cancels out my miles. But now I have feet per hour. I don't want hours on the bottom. I want to cancel the hours out and get them into seconds. Okay, well, I got to think about how that conversion works. How many seconds are in an hour? Well, I know that there are 60 seconds in 1 minute, and I know that there are 60 minutes in 1 hour. Now, if I combine those, it ends up being 3,600 seconds in an hour. But I'm going to make these conversions one step at a time. It doesn't really matter. So I'm going to say, so hours, I want to convert hours to minutes first. So I'm going to put 1 hour on top. That way the hours cancel. And I want 60 minutes on the bottom. And then I'm going to convert minutes to seconds. So I'm going to take 1 minute on top, that way my minutes cancel. Oh, I already have my hours canceled. And I want 60 seconds on the bottom. And so now everything canceled, right? I've got a pair, everything's got a pair, one on top, one on the bottom, kilometers, miles, hours, and minutes. There we are. Excuse me. Except for feet and seconds. Those are the ones that don't have a pair, so those are the only ones left, and they're in the right position. Feet on top, seconds on the bottom, feet per second, right? So that works out. It's kind of cool. I just like seeing it play out. Long dimensional analysis problem. And remember, each of these fractions is really 1, right? It's 100 times 1 times 1 times 1 times 1. So we're not really changing anything, right? You're changing what it looks like, you're changing the units, but you're not changing the actual rate of speed that the object is going. Okay, and so now I got to put all this into my calculator. So I want 100 times 5280, and I'm just going to do this in stages. 100 times 5280. There's other ways to punch all this in at one time. That's 528,000. Then I'm going to divide everything on the bottom. I divide by, so I divide by 1.6, hit enter. That's 330,000. Then divide by 60, and that's 5,500. And then divide by another 60, and that is 91.6 repeated. So it's about 91 2/3. But I'll put in decimal form. So it's 91.6 repeated feet per second. Okay. So if you're traveling at 100 kilometers per hour or 62.5 miles per hour, you're covering almost 92 feet in every second. Okay. Yeah, 92 feet is the distance from my house to the road out front. Actually, my driveway is 90 feet long, I think. Just kind of remember that from when we built our house. So anyway, so it gives you a little perspective. It's an average sized driveway, okay, in 1 second. So kind of cool. Anyway, that gives you some idea. This is kind of a bonus video. I don't know that you see a lot of these, if any of them, in the my math lab homework. They do show up in the section in the textbook. There's a little bit of this, but I wanted to give you a little bit of a perspective of some other things we can do with length conversions, and then if you incorporate a little time in there as well, we can really expand on this. Now, to make this go even further, if you get into physics or chemistry and you're looking at measurements of energy or measurements of force, or some other things that have more units involved, then you can get dimensional analysis problems like this where you're working on conversions. They really get lengthy. Okay, that was a pun, that was bad. But anyway, you can get some really cool dimensional analysis problems where you're just trying to keep track of making sure your units are always canceling out as needed.